Hello everyone, this is DSA Zindabad. Today we are going to solve the ninth question of our Goyal DSA sheet, and the question is best time to buy and sell stock second. Now let's look at the problem statement. You are given an integer array prices where prices I is the price of a given stock on the ith day. On each day, you may decide to buy or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it then immediately sell it on the same day, right? Find and return the maximum profit that you can achieve. So what we need to return? We need to return the maximum profit, right? Now let's look at the first example. It is 7, 1, 5, 3, 6, 4, right? Now we need to maximize the profit. Maximize the profit. What things we need to keep in our mind? We can only hold at most one share of the stock at any time. What does it mean? Like, let's say if we buy the stock on the first day, assuming we have zero-based indexing, right? On the first day, we buy the stock and then we'll sell the stock on the second day, right? So at most, we can only hold one share at a time. Then after this, again, let's say we have again buy the stock on the third day, then again sell the stock on the fourth day. Then what will be the total profit? It will be 6 minus 3 will be equal to 3 and 5 minus will be equal to 4. So we'll just add all of these profits and try to find out the profit which will be maximum. Profit which will be maximum. Now let's try to guess the output of this example. Like let's say I made this array once again 7, 1, 5, 3, 6, 4. Right. So let's say we'll buy on the day 2 price equal to 1. Let's say I'm denoting this as a buy and sell it on the third day, right? Sell it on the third day when price is equal to 5. Then sell it. Then what will be its profit? 5 minus 1 will be equal to 4, right? Now again, like it will be equal to 4. Then buy on day 4. Day 4, its price is 3, right? So let's say we are going to buy this and sell it on the day 5 when price is equal to 6. Sell, right? Then again the profit will be equal to 6 minus 3 will be equal to 3. 6 minus 3 will be equal to 3, right? So the total profit from this array will be equal to 4 plus 3 will be equal to 7. So 7 is our answer. And this is the maximum profit that you can achieve from the input array. From the input array, right? Now let's try to discuss one more example, right? So that this thing is clear to all of you guys, right? Let's say we have this array 1, 2, 3, 4, 5, right? This second example 1, 2, 3, 4, 5, right? Now let's say we'll buy on day one, and sell it on the fifth day when the price is 5. When the price is 5, right? When we need to sell, when there is profit. Whenever there is a profit, it means our selling price is greater than that of the buying price. Then we can only make our profit, right? This is the required condition. So its profit will be equal to 5 minus 1 equal to 4, right? So now let's try to visualize this thing, like how we are buying the stock, how we are selling the stock, right? Now let's jump into the approach, like how we are going to solve this problem, right? So let's directly jump into the approach. So let's take this example. First example 715,364. 715,364, right? So now let's try to make a graph for the same. And this will be price and this will be day, right? Let's say this value is 7 and this value is equal to 1, 7, 1, and this will be equal to 5 and this is equal to 3, and this is equal to 6, let's say, and this is equal to 4. So our graph looks something like this. So ultimately this will be our stock graph, right? Now we need to maximize our profit, maximize the profit. And we need to keep this thing in our mind, like whenever we try to get the optimal solution. So we just need to traverse over the area only once, right? So now, as you can see, like whenever there is a local minima, right? Whenever there is a local minima, then you need to buy the stock. And whenever there is a local maxima, then you need to sell them. So now, since 7 is the like local maxima, so uh, this one is our local minima. Why this is our local minimum? Because it lies between two maximum values, because the left value is, which is 7, is greater than that of the 1, and the right value is also greater than that of the 1. So it's our local minimum, right? So we'll directly buy the stock on day first, right? Now, as you can see, like since 5, moving on to the 5, like since this is not either of the local minima or the local maximum, because the left value is less than uh, that of the 5, and the right value is also less than that of the 5, right? So it can be considered as our local maximum. So what's the definition of local minima and local maxima? Local minima is when the left and the right value, what I mean, this left value and the right value, both are greater than that of the current value. And what's the definition of local maximum? When both the values like left and right are less than that of the current value, right? This is the example of our local maximum. So we'll just directly subtract those values of local maximum and local minimum, and this will be equal to 5 minus 1 will be equal to 4. Now our pointer will directly move to 3. Now, as we can directly see, 3 is our local minimum, right? Local minimum. Why is it local minimum? Because left and right, both the values are greater than that of the 3. 3 is our current value. We need to keep these things in our mind, like what's the definition of local minimum and local maximum. Then we can easily figure out when we're gonna sell the stock and when we're gonna buy the stock, right? Now, so directly we'll just buy the stock when its price is 3. Then moving on to 6, we can see like 6 is our local maxima. Why is it local maximum? Because both left and right value are less than that of the 6. So we'll just sell the stock on this day, and ultimately our profit will be equal to 6 minus 3 equal to 3, and our answer will be equal to 4 plus 3 equal to 7, right? Now let's uh, do a dry run on the second example, which is 1, 2, 3, 4, so that this approach is clear to all of you guys, like how we are going to buy the stock and when we are going to sell it, right? Let's take this example, which is 1, 2, 3, 4, 5, right? And so this will be our graph for this nums array, right? And it's, let's say we are at this one value, right? So this will be this can be considered as a local minimum. Why is it local minimum? Because left value, there is no left value over there, and the right value is 2, which is greater than that of the 1, right? So it can be considered as a local minimum. So we'll directly buy the stock on the first day, right? Which is 1 over there, right? We'll directly buy the stock, right? And now we can, as we can see, like 2, can 2 be considered as our local minima or local maxima? Since, as you can see, like its left value is 1, which is 2 lies between 3 and 1, right? So it can't be our local maxima and local maximum, because for local maxima, what is our condition? Both left as well as right, these values should be less than that of the current value. but here this is not so, right? So we'll directly move to the 3. Can 3 be considered as a local maximum? No, 3 cannot. 3 can't be a local maximum because it does not satisfy the condition, right? Same goes for 4. When we come to 5, when we come to 5, as we can directly see, there is no right over there, right over there to that of the 5, right? There is no element after 5, right? So its left value, which is 4, it is less than that of the 5. So our 5 can be considered as our local maximum, right? So we'll directly sell our stock on this day, on the fifth day, right? So our current profit will be equal to 5 minus 1 will be equal to 4. So this is our answer. So you guys be like, we just need to figure out the condition, like when we're going to sell the stock or not. Like we need to figure out the local minima and local maxima, right? From this, like in the example also, it is mentioned that buy on day 1 and sell on the day 5. Hence, the profit will be equal to 5 minus 1 will be equal to 4, right? So we just need to figure out local minima and local maxima for the same, right? But we can, there is also like one more way to solve this problem, right? Let me just do a diagram for this problem, right? For this problem, let's say we have this array, right? 1, 2, 3, 4, 5. Let's say we just buy the stock on the first day and directly sell it on the second day, right? So our profit will be equal to 2 minus 1 will be equal to 1. Now again our pointer will move to 2. Now again we'll just buy the stock on the second day and then again sell it on the third day, right? So again our profit will be equal to 1. 1 plus 1 will be equal to 2, right? So again we'll buy our the stock on the third day and sell it on the fourth day. So our profit will be equal to 3. Now again, we'll buy the stock on the fourth day and sell it on the fifth day, right? So our profit will be equal to 3 plus 1 will be equal to 4. So 4 is our ultimate answer. So there is no need to to figure out local maximum and local minimum. We just need to check and local minima, right? So we just need to check whenever there is like let's say this is our nums array, right? We just need to check only one thing: when nums of I is greater than that of the nums of I minus 1, then we can directly sell the stock, right? This is our main condition. We can also do this problem with the help of like finding the local maximum and local minimum, but this will be a cumbersome process. Like we just need to put those condition of local minima and local maxima in the code, but our code will run perfectly fine by running this condition, right? This is the shorter version of the like code, you can say. I hope this approach is clear to all of you guys. Like there are two methods to solve this problem, like by figuring out the local maxima and local minima, or we'll just directly code this thing up so that this approach is clear to all of you guys, right? Now let's try to code this thing up, right? Initially, let's say our profit will be equal to 0. Now we'll directly run a loop from 1 till I less than prices road size. We'll increment our pointer. Now we'll check if prices of I is greater than that of the prices of I minus 1. If this condition holds true, then we just need to add that thing to our profit, which is prices of I minus prices of I minus 1, right? And in the end, we just return the profit. Return profit. Now let's try to run this code. Yeah, this code runs perfectly fine. Now let's try to submit this thing up. Yeah, this code runs perfectly fine. Now let's try to discuss the time and space complexity for this problem. So here we are. So we'll just initialize a variable which require constant time. We are just iterating over the prices array, so it will require big O of n time, right? So ultimately, time complexity would boil down to big O of n, and its space complexity will be equal to big O of 1, since we are not using any extra space over there, no extra space, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.